All right, 3. Now we're moving into a tap hole area. 3 and 4. So when we're doing a tap, did everybody get a chance to watch a video yesterday? If you've never seen a tap or a die work, Missy, did you get one? Do you understand it? What it's doing?
Yeah.
One? You didn't get to watch one yesterday? They put that on your bucket list. It should happen today. Have you ever tapped a hole or used a die set on a shaft? Okay. For you to really kind of, you ought to at least see what it is so that you kind of understand what's going on behind the scenes. Now, again, as drafters, are we tapping holes? No. I mean, that's a machinist role, right? Fabricator's role. But it's nice to know what they're doing. One thing, you don't ever want to tap a hole unless you have to. You will, those things are fairly expensive, they will break, they break even for people that do it all the time. Because they're very high strength, very brittle. And so if you get any type of jamming, you can do it. When you tap a hole manually like this one, it takes quite a while. Because you got to cut a couple threads, you take it back out, you clean it, you do a couple more, and you just in and out all the time. And then you still probably break it at the end, if you're me. But be that as it may, to draw the tap, okay, first we got to look it up and see what size it is. The tap is the drill that comes and puts this main hole through. It's usually the tap drill is equal to your minor diameter of the thread. So it will vary what tap drill you use because it depends on what thread you're cutting. But if I'm doing a 1/2" -20 that's a coarse thread, I would use a different tap drill than one I would use for like a 1/2" -40 extra fine thread because it doesn't have as deep of a thread. Yes?
So how you used to explain the tapping, you did 2954 instead of the, you used it from the chart. That's
Yes.
typically how you call it the diameter?
Mm-hmm, yeah.
Okay, so you call it.
Yep, say diameter. Now, when you put your dimension on, remember we always point to an outside object line. You list everything with this note on the hole in the order of construction. So the tap drill's first, the thread is second. If I had a counter bore or a countersink, that would be third. And I would put it all right here in one note. And that will explain everything they need about that. Same way we put our house together where we did site plan, foundation, basement, right? It's the order that it was constructed. We follow the same protocol when we're doing our notes. So about all you have to do here is just locate it and then give your thread note. Now, I did reference you on this to Appendix A32. So if you want to turn there. How you read a chart like this. Did you go down the left-hand side and find your nominal size? In this case, we're a 1/2". And that's right down here. You have two of them to choose from on this chart. The bottom one is a 20. Okay, so that's a UNF. A UNF. So make sure you say that in your note. Your tap drill that you're using is 29/64, or the diameter is 0.4531. You usually list the fraction because that's the way the drill is labeled in the shops. Now, did that match up with theoretical machinist? Because I know, Lisa, when I talked to you yesterday, you should confirm this number.
Mhm.
Is it the same thing you got off of there?
Yeah, I did the diameter.
Missy, I think you set the website up, right? Are you in the tab section? I think I got the same number when I looked at it. Let me go there real quick. So I'm going to go to my little website, go to tap drill size. Basic diameter is a 1/2 inch. Got 20 threads per inch. We'll do a 75% of the thread. Compute. 0.4513. Yep, they match up. Which really kind of surprises me, because our textbook is 6 years old now, before it's been revised. I would have thought the tolerances on this would have changed a little bit. Okay.
So that's the one you would go with if there's discrepancy.
Yeah, 29/64 is what it is. There is a slight discrepancy in those 2000s. All right, now when you're drawing the tap, oh, sorry, Cheryl, yes.
I thought you were leaving, okay, I was just wondering about the leader line position, where it's at the top versus the bottom. Is that giving you new information, or is that just the way it's set up?
No, you can't really see some stuff. I got stuff with the colors on here. This was done in a really old version. No, you're gonna put it, your leader, it should be radial, right? Always radial. Point to the outside object. You should be a 1/2 inch off. Point to either the middle of the first line, middle of the last line, one of the two. We never point to the middle. Okay? So it's always top or bottom. And then it's where it reads well. Certainly, remember, we've got grouping and these other things that we try and do with drawings to make them read well. In this case, my bottom was kind of filled up with some location dimensions, so I put it up top. How much are you supposed to add to the length for the tap? This little section right here. Because the thread's going to go right at that end line. Okay. Is that a 1/4 inch? Isn't it a range?
This is the range, yeah.
There's an example on this on page 922 of your text. And it's the exact same example in your handout when you want to find it, but I'll just kind of look at the figure. Okay, so they just kind of recommend give it an 1/8 to a 1/4. And yes, like you folks said, most of the time I'm almost always go a 1/4. The more you can give them, the better for those cuttings to go down in there. Any question on 3?
I
Yes.
actually I use the diameter that they gave us for tap on there, but it wasn't exactly it was a little bit smaller than one I used for my minor. Is that okay, or do you want me to make sure?
No, it is okay. Yes, remember, we're doing an approximate. In fact,
Okay.
if you read through these examples, it tells you if you've got a really fine thread, this one's pretty, 16 of them on a 3/8 bolt, you can barely even see the difference here.
Okay.
Now, they did say move one, but which one did they say to move? The minor diameter, which is the major diameter of your tap. It's this inside one, right? They said if you do a drawing and these two are so close to each other, move your minor diameter. Take a drafting liberty, get it away from it a little bit so you can see that it's a thread. And it's buried in one of the examples. And that's just a display thing. If it looks great when you're printing it, don't move it. You're just looking for those double lines that are so close together you can't really tell what they are, right? These seem kind of technical, where you're looking around for different examples and stuff. They're fun draws, though. I mean, and it's a matter of just taking things step by step by step. Get into these examples, do them. If you're a little confused, right off to the side, do it again, and see if you can pick it up. If you're still a little confused, that's when you get me involved, and I'll sit down at your machine with you, and we'll go through the process. Number 4, any questions on that one? 4 is pretty much the same thing, although you are changing the thread a little bit. And in your inside of you're doing internal threads. When you do the fastener, okay, so you're putting a fastener in a tapped hole. So we've got a threaded hole here. There's your threads for the tapped hole. Okay. But then this is the fastener that comes in. We did do this one as schematic representation just for one of them. Okay. You're going to hate the schematic. I shouldn't say that. That kind of predestines that you're going to hate it. Remember what we do here. So we've got these 2 lines here, that's pitch. They represent your crest of the thread from here to here. And inside of it, you chop these off at your minor diameter, and they're half a pitch. They're your root thread. Okay. These are going to be very close together. You're going to want to play with the line weights. I would probably start on this to make it work. Your majors or your crests, go at like 012 for those line weights. And then for your root, put them on a layer like 006. Okay. And in actuality, the interior ones are supposed to be thicker than the crest ones. Let me just kind of point it out. I'll just look on page 923. We have an example of schematic. So do just the opposite of what I told you. The interiors are 0.012. The exteriors are 006. So when you do these, since this is so small, do that at an 012, 006. Don't hesitate to adjust them once you print and see how they look. Because it depends on scale and all that other jazz. Remember, 3 C's, clear, concise, complete. That always trumps any of these rules that we do. Yes, Lisa?
Back on your drawing, where's your section line? Where's your cutting point line? Show that section.
If it's a full section, down the center of the object, and the location of the cutting plane is obvious, you may omit it.
Oh, since it's obvious.
Isn't that one of those
That's
rules for a
right.
full section?
There, take it out.
Now, if you want to include the cutting plane line,
Yeah.
by all means, please do. But back when we did sections, I know I mentioned this because I do every year, full sections, you do not have to include a cutting plane line if the location of the cut is obvious. And when we did sections, I said the cut of the plane is never obvious, why we go through chapter 16. Now, we're past
That's
that.
obvious.
Okay. Now, if you, please include cutting plane line if you want. All right, we good there? Get me involved if something's not working for you. These are, yes, Dave?
How far did you go, like, from the end before you started your threads on that last
On this one here,
one? Yeah.
Yeah.
this is a fastener. You're putting, this is a bolt that's been put in this tapped hole. So you got your tapped hole from over here that's just a tapped hole, right?
Yes.
Just take this whole thing, copy it over. Okay? And now all we're doing is changing it. It's the exact same size, except instead of 20 threads per inch, we're going to 13. And on this one, we're putting a fastener in. So this is a 1/2 inch to 13. Notice it's a 2A. This is a screw.
So why, but what's the distance that you like waited? to
Yeah, so
start
how do you
the
know?
threads on the
You're building record.
Oh, it's given to you, no. Should have the length on there. By 1.5, it's in your,
Well, that's the length of the fastener, but,
uh-huh.
But how do you know when to start the threads on?
so you didn't start the threads at the end. We did.
Because they don't start at the top of your like right up by the bolt. There's like a little bit of offset.
Oh, right there?
Yeah.
It's a machine screw though, right? No, so you'll thread it all the way to the top.
Oh, okay.
It's a machine screw, thread it to the top.
Okay.
I think I read somewhere to make the washer on the thing 1/32, instead of 1/16, so I have to go back and make mine bigger. Did you
Yeah,
know?
it does say 1/32 in there for a washer face. That's the same as that .02.
Mhm.
I think 1/32 is really 0.3. Get that out to a 16.
You won't be able to see it in front of you.
Right.
Okay.
All right, nice little drawing. Any other questions? All right, that took a little longer than I thought. So when we're dealing with fasteners, okay, so we got to kind of remember all the important parts here. Okay, so we need length, right? We need the length of the fastener. We need type, which type can be hardness, head, body, all that type of stuff. We need our thread. And I think that's about it. So for us to identify, this is what we want to be able to identify is all of these items so that we can draw them. So if you want, you can grab your sheets out of the mailbox, those of you that are done. Let's take a break. We'll come back. I'm going to have a bunch of stuff spread across a couple tables, and we're going to start identifying these and get a little practice at it. Okay. So take a little break.
Hey, Pat, you here?
Sure.